Okay, so can you please come in and close the door? Thank you. So this is the summary meeting of the Think2Think research group at IETF97. This is not an IETF meeting. We are not making standards today. It's an IETF meeting. So this is a research group. I'm going to talk a little bit more about that in a minute. But we still have blue sheets and we are looking for note takers. Do we have note takers now? We have one. Okay, thank you. So are you going to do it on the Etherpad? So maybe somebody can chime in and fill in the blanks a little bit.
So if anyone, and more than one can of course volunteer on the note taking. So I sent the, excellent. That was Christian. Thank you. So I sent the link to the Etherpad on the mailing list like an hour ago. So you should find it in your email.
Okay. People are still filing in here. The whole elevator situation is making 20-minute break, making the every meeting 5 minutes shorter. Okay, so can you close the door? Can someone who's close to the door close the door? Thank you. So this is an IETF meeting. So we have our own IPR guidelines, but they are the same that the IETF uses. So, but do look them up and show them to your lawyer and all that. Right. Yeah, I just want to point out the research group has a mailing list, and there's a little trap here because all of our stuff, of course, ends with @ietf.org, except sometimes. So sometimes you have to look a little bit closer whether there is an ietf.org or an ietf.org there. And maybe quite importantly, we tend to put our meetings on GitHub. So each meeting has its own repository, and the repository for this meeting is github.com/T2TRG/2016-IETF97. So there you can find the slides that we are looking at. We have only 1 hour, so we have a pretty compressed agenda. But still, if you have a question, please ask it. We will get a quick update on the Web of Things activity in the W3C. We will talk about the security considerations document, which is probably the most substantial document that we have agreed as a research group to work on. We will discuss the RESTful design and hypermedia subject. There are a number of documents here. One may become a research group document very soon, and other are a little bit more explorational in nature. And finally, we will have a quick discussion about Yang as an interaction model for Komi. Again, none of the things that we are talking about here are standards, but some of them do try to gather a little bit of a consensus. For instance, the security considerations probably do collect information that many people have been collecting over the last couple of years. Okay, quickly, what is the research group about? The Think to Think research group was officially chartered a year ago in December 2015. And we look at open research issues in turning a true Internet of Things into a reality. So I don't know who of you was there on Tuesday at the ISOC panel. A few. I think you missed something. We are interested in making an internet a reality where low resource nodes are full citizens, are not just devices that can talk to a big brother in the cloud, but actually can interact, maintaining some of the invariants of the internet. And of course, within this really big subject, we focus on issues with opportunities for IETF standardization. But we do that full stack. So if somebody comes with an adaptation layer problem, we are as interested in that as when somebody comes and wants to talk about human rights issues in think-to-think communication. Don't know how that would work, but we will find something. Okay, so again, we were chartered a year ago. We have had a pretty full calendar this year. So we have done research group meetings, partially co-located with W3C. We have had one co-located with the IAB Semantic Interoperability workshop. We had meetings with the IETF at the IETF locations. We participated in the software update workshop. The Riot Summit in Berlin, talking to implementers is very much of interest to us. So we just recently had an implementers meeting with the EclipseCon conference, which was very interesting. In particular, there were lots of lightweight M2M people there. And we just had a joint meeting with IC Energy a couple of days ago. So we have 3 deliverables in progress. We will talk about 2. And we are really also interested in outreach. So for instance, we have had meetings with OCF, with Bluetooth people, and we want to make sure that we talk to other organizations that are doing interesting things in this space. And we have a pretty intimate relationship with the W3C activity because that is very close to the problems that we have to solve. I'm going to skip this slide for lack of time. Our 2017 planning is wide open, so we kind of did our calendar for 2016, but the next step will actually be finding opportunities in 2017 to meet again. I'm sure we will use the summer meeting for something interesting, but we'll see. We haven't really scheduled that very much yet. So on the meeting we had on Sunday, we had a joint meeting with IC Energy for 2.5 hours. 2.5 hours is not much. In particular, if 2 established communities meet each other for the first time in a room. But IC Energy has a lot of perspective on IoT already. But of course, with a view to, we have this hammer, and how is IoT a nail? And Think2Think research group, on the other hand, has grappled with issues that are just the staple issues of the IC Energy, such as data naming and so on. So it makes sense for us to talk to each other. And we presented a couple of, we had presentations for a couple of ICN IoT projects and discussed different aspects of semantics and security. So again, this was only 2.5 hours. We didn't get very far, but it seemed to us that we will continue that. So I expect us to have further joint meetings with IC Energy in the future. And we might even want to have cross-review of documents. There is an IoT architecture document being prepared by ICNRG, so maybe that's something we will look at. So this was the agenda. We had 4 research talks, and for me personally, very interesting talk was by Thomas Schmidt about an industrial application of ICN. And then we went into discussion. Okay, so so much for the status of the working group, of the research group.
Hi, Lee Howard. I'm sorry for interrupting. I've noticed we have several people standing in the back who can't find seats. And I've noticed we have a lot of people putting stuff on seats next to them. Can people please make room and raise your hand if you have a chair next to you? Find a chair.
Come in. You're welcome. Thank you. That was a good point.
Well, thanks for the presenter, Carsten. I'll wait until everyone found a seat. And we refilled the row in the back. There were some seats left if you're looking for some. Okay.
You don't have to have read the draft.
That's new, isn't it? Oh. I just start? Okay, yeah. I have some updates on the Web of Things activity at W3C. So just to recap, what is this about? So the mission is definitely not to create a new standard in the W3C for this. So we are aware that there is a lot of activity. So there are a lot of alliances and platforms out there. What we try to do is create building blocks that are able to complement those existing standards out there to ease the integration of the different platforms that we have across the different application domains. And the central idea is to provide semantic metadata for the existing platforms so that we can describe how to interact with these things of a specific platform. And another thing we want to tackle is how you develop IoT applications so that it becomes easier to actually write applications for the Internet of Things and to get ultimately something similar to the web browser that is a runtime for web applications, but have that for actual things. And for that, we are currently targeting those building blocks. So we have the word scripting API, so that we have some kind of common API that you can write an application against, and that should then run on different things. Again, it's a building block, so you're not forced to pick that or implement that, but it's something, if you say you want to support this is something you can integrate in your platform. Then the next thing, probably the central part, is the Web of Things thing description. So this leverages semantic technologies to describe how interfaces of things work. So on the one hand, there's this support for the scripting API itself. So you need to parse these thing descriptions and then want to write code that can actually work on this. So for that, we have a connection up to the scripting API from this thing description, and we have these protocol mappings. So for instance, a lot of platforms leverage co-op. So there's a co-op binding for one M2M, for instance. OCF uses co-op, but they use co-op in a different way. And what we try to do in these mappings is to describe how they use co-op in a different way so that you can have a vanilla co-op stack and then produce messages that will be understood by the OCF device or by the one M2M device. And this is then in the end also part of this thing description. So you see the thing description is basically the central part of or the central building block, and for application development it extends to the scripting API, and for the interconnection it goes down to the protocol mappings to create messages that will be understood. And kind of part of all of this is security and privacy. So we also want to provide means to describe the security mechanisms that are used by the thing, and also have checks that you can write applications that are able to express privacy needs, for instance. So how is this work organized in the W3C? So for 1.5 years, we have now the Web of Things interest group. which is mainly for exploration, so looking at technology out there and identifying building blocks that might be worth standardizing. And it's the group that is open for collaboration, so we actually have quite a number of liaisoning ongoing, so with the 1M2M, with the OPC Foundation, and we are currently setting something up with OCF. And yeah, so we exist since April 2015. We were rechartered in August this year with the more long-term run and the setup with the proposed working group, which I will introduce in a few minutes, or 1 minute probably. By now, we already have 210 official participants in the group, so those who signed up through the W3C membership login and so on. And so far we had 7 face-to-face meetings, started in April 2015 in Germany. And this year we had 4, started in January in Nice. Then directly after the Buenos Aires IETF, we were in Montreal, Canada. In summer in Beijing. And in September, there was the TPAC, so the annual big meeting of the W3C, where we met. And as you can see here, we number of these meetings were actually joint meetings with the Think2Think research group. So the working group, currently it's still in proposed status. The working groups in W3C are those who can actually do normative standardization work. So you can compare it a bit. W3C working group is like an IETF working group, and the interest group is like an IETF working group. So that's why the interest group also meets with the Think2Think research group. We have the proposed charter. It's out there since end of August, I would say, yeah. So we had the AC review, so that's the what committee? A committee in the W3C, I forgot the name, too many abbreviations, that looks at these charters and then decides or votes whether this should be a working or should become a working group. You can have a look at the results here. The summary is we have 49 supports as is. 4 member companies had comments, but support the charter anyway. And we had 2 comments that would formally then object if you do not apply the changes they propose. And that's basically what we are doing right now. We are, together with W3C management, resolving those issues. In summary, one was about RDF dependency. So we shouldn't force dependency on RDF or these heavyweight semantic frameworks. And that kind of shifted to a comment that RDF or semantics classically created some complexity in the setup of the working group or the solutions that you work on. So one thing is we do not force a dependency, so it's basically an extension point because there are a lot of member companies that actually want to provide rich semantic tooling, but then there are also others that just want to benefit from a common format that can be parsed by classic JSON parsers, for instance. And for the complexity, we basically have a plan now how to set a priority of the different deliverables. So the central one is still the thing description. And if there might be a conflict based on the semantic frameworks in the scripting API, for instance, the thing description itself gets priority, and we have to find a different solution or adapt the scripting API solution for that. On the scope, that's already what I presented. So the thing description itself becomes the central piece. It has the priority, and it's also what is the greatest interest of all the members. And the scripting API and these protocol mappings become kind of secondary things, but they are connected. So you cannot even design those independently. So it wouldn't make any sense to not work on those. And finally, there were some security considerations or hints that IoT is dangerous, especially with the recent attacks. So there was more emphasis on that we have the right checks. So we actually also established this kind of model of running code in this interest group and working group. So we actually implement the drafts in parallel, and we are planning to have a security testing before we actually go to the new status of those documents. So before we have the first public draft, for instance, we will have rigorous testing and those who had the objections on this actually will help to develop proper testing on that. So it were basically browser vendors who had some issues here, but they can definitely also support us in coming up with the right testing, how to do that, how to roll it out. And yeah, that's about the update. I summarized a lot of links here that you can follow up to get more information on this. And I don't know if you have time for questions or if there are any questions at all.
Yeah, there are still seats here up in the front, so you don't have to stand in the back. You can go to the front. Where are the blue sheets? So we get a bigger room next time. Make sure you sign it. Okay, so no questions?
Microphone? No, you need to go to the microphone. It's mandatory.
Yes, for the remote participation, we need to use the microphones.
Hello, I'm Ding from Sunshine University. I want to ask you, can I participate the interest group as an individual member?
So it depends. Your university doesn't have any contract with W3C. So sometimes it's possible to get invited experts in there. But also the work is public. So if you follow the links, you can see what we are doing on GitHub. You can just comment on that. And I actually don't know what happens if you sign or subscribe to the public mailing list. I mean, it's supposed to be public, and the IPR policy is also pretty loose. So there is no policy in the interest group. So that's why we keep the interesting work in the interest group, and then only the working group is kind of the where you have to contact your lawyer and so on.
Yeah, I see. Yeah, thanks. My name is Dean.
Thank you. Mohit?
Hello everyone, I'm Mohit, and I'll be presenting our draft on security considerations for the Internet of Things. This work was done together with my co-authors Oscar and Sandeep, who unfortunately could not make it to this IETF. So I'm sure some of you are aware about the history of this document. This was originally submitted to the core working group several years ago, but now it has been decided that we will work on this document in the research in the T2TRG, and the idea being that the IoT related drafts would reference this draft in the security considerations. So this would then act as a repository for security considerations to which other drafts would reference. So since it hasn't been presented formally in the T2TRG, the chair suggested that I actually present what does it contain rather than just presenting what has been updated. So I'll briefly present what this draft is all about. So the first thing the draft contains is the thing life cycle, so which basically describes the life cycle of an Internet of Thing device. You know, it gets manufactured on the factory floor, it goes through the supply chain, it ends up probably in a shop, you go and buy it, and then you need to physically install it and commission it. So kind of run the bootstrapping process with which it would become operational. And once that it's operational, you will have things like software updates, reconfiguration. So for example, if you change the battery, then you need to run the bootstrapping process again, and so on. Once the operational cycle or the lifetime is over, you decommission and remove it, but that doesn't mean that the device is unusable. So you might have a change of ownership where you sell the device to someone else or someone else acquires you and so on. The device then continues the life cycle all over again. So yeah, we had one section describing, you know, all the different phases of the IoT device life cycle. So then we have a section on threat analysis. So basically, what kind of threats does IoT device face? So we could have, for example, an untrusted manufacturer or an incompetent manufacturer. If he is responsible for putting the keys in your IoT device, does he make a copy of them, or does he like unknowingly reveal them, and so on? You have physical attacks. So if your device is installed somewhere and your neighbor goes and replaces them or takes them home, on the network level, you have attacks like eavesdropping and man in the middle. And of course, eavesdropping is not just a security threat, it's also a privacy threat. A lot of these Internet of Things devices are extremely constrained in terms of the resources they have. So in terms of the battery or energy or computation and so on. So you can always have denial of service or denial of sleep attacks. Then, of course, you need to do software and firmware updates because these devices are going to be deployed for many, many years. But it turns out the software and firmware update processes or implementations may itself be vulnerable. So if you have followed the Internet of Things software update workshop, you might have seen the example of TR69, which is one of these protocols that is used for doing updates and firmware updates, which was found to have certain holes in it, and an attacker can use those to kind of replace your firmware with a malicious firmware. Of course, there's also possibility of routing attacks. So then we know what are the threats that your IoT device faces, and then what's the challenges in securing against these threats. So the first is just the heterogeneity. So you have extremely resource constrained devices and full-blown laptops and devices that are much more computationally capable. And how do these devices talk to each other? And this also relates to the second challenge, is like you have a device that speaks co-op, and you have an internet service that speaks HTTP or HTTP2. So how do they interact? You probably need some kind of a proxy or protocol translation, but then how do you still ensure end-to-end security? So this is of course a challenge, and especially not just protocol translation, but if you have aggregators and so on, how do you still have end-to-end security? Software update is a big challenge. Many of these devices don't have memory management units. So if you were at the IoT software update workshop, you might have read about it and some possible ways to solve them, but it's a big challenge. Then we got some comments from Stephen Farrell, based on which we added new challenges. So one was, how do you verify that your device, IoT device that you just bought, is behaving the way it's supposed to behave? So for example, I go to the shop and I buy this TV and bring it home, internet connected TV, and bring it home. How do I know it's not sending some data back to the manufacturer? How do I know especially that it's not sending any private information to the manufacturer? Exactly. So end of life is again a big challenge. So what happens when the manufacturer does not exist or refuses to support your device? Is it still usable? Can I still do software updates? And those kind of things are extremely challenging. So how do you handle those? And can I do some pen testing on my IoT device, even though it's very resource constrained? How do I do pen testing? And how do I ensure quantum resistance? So if my IoT device is going to be deployed in the wild for 20 years, probably there might be a quantum computer, and how do I handle those things? How am I doing on time? So then we have several sections that discuss into profiles, into different kind of architectural considerations, and state of the art. So like depending on your application scenario, are you deploying it in a home, in an enterprise, or in a factory? You will have different requirements. You'll have different kinds of IoT devices themselves. So some will have hardware support, and some will have TPMs, and some might not. So we discuss about that and what kind of trade-offs you have between centralized and distributed security architectures. And then we cover some of the ongoing work for IoT security. So for example, minimal IKE, and we had the DICE working group which specified DTLS for for constrained devices, and how do you do lightweight IPsec. So that's something ongoing in the LVIG working group. So we cover all that in the draft. So yeah, that was kind of an overview of what the draft contains. And now I come to the part what has been changed since the last version. So in the version that was submitted to the core working group some years ago, we had the life cycle, the considerations, state of the art, and then all the challenges and profiles. But in the version that is now in the research group, here's some changes we made. We did some cleaning, some updates, reordered stuff, added new challenges that we got from Stephen Farrell. But also one major change was we removed the bootstrapping, so that all that is now in a separate document that provides all the different bootstrapping options you have for Internet of Things devices. So here's next steps that we plan to do, and we are open for comments and feedback. I think the draft would still take at least 1 or 2 more iterations before it's really ready for publication. So it's relatively long, and that's always we as authors run into the problem. How do we keep it with useful and relevant information, but at the same time that it's not too long and people actually read it. So we'll try to still make it more concise, but also how do we ensure that it's more smooth in terms of the flow? So how is it more uniform in terms of its structure? And for that, we are proposing that we have these security pillars, and basically in each of the section we structure it according to the pillars. And these pillars are what kind of architecture you have. Is it centralized or distributed? What kind of a device you have? Does it support hardware encryption, and does it support TPM where you can save keys and so on? And what kind of network and application security mechanisms and protocols it requires, and can it actually support them? So right now we have some threats in the threats section, but they are rather ad hoc, and you can see that it's written by different authors over time. So it needs a little bit of more work so that it's smooth. But we are also thinking that we organize the threats based on the life cycle we present in the first section. So what kind of threats do you face in the bootstrapping? What kind of threats do you face in software updates? And what kind of threats do you face when you do ownership handover and things like that? So for the security profiles, again, just add a little bit more detail, but making sure the document doesn't become too long. And what kind of security properties do you expect in different application scenarios? So state of the art, this will still require some work. So some of the references are out of date, so they need to be updated. There's always new work going on, so we need to add as much of it as we can and include all the new references. And the challenges, so we added some new challenges such as pen testing and so on. So trying to make sure that it follows the same structure as the rest of the document. So we just describe the challenge, and here are the potential solutions that you can use to address those challenges. Yeah, I think that was my last slide, so I'm open to questions and feedback.
Hi, Mike St. John's. I've gone through this document a couple of times over the years, or similar document, and I'm kind of frustrated with a couple of things in here. First thing is the threat section is all about threats to the things, not the threats from the things, and that may actually be the biggest problem we have to deal with. Okay, the other piece of it, sorry, I'm a little bit, I've had a cold for a while or something that's been causing me problems. No, I think I'm going to stay with that one. I think we need to start thinking about the Internet of Things, not just like we thought of PCs and everything else, but the fact that we don't have the same model of control over them. With respect to what we're talking about here, thinking about the threats from these devices is important, and probably more so than threats to the devices. Going back, especially to things like the cyber physical threats, the denial of service, the distributed denial of service stuff. For example, how do we keep these devices from becoming a problem rather than the solutions we want them to be?
So point well taken, but we will not have any solutions in this document. So we can, of course, note that this is a challenge, an issue. We need to be aware of it. You know, physical attacks, like you pointed out, those can be added, but I don't think we'll go into actual solutions of how do you mitigate DDoS from IoT devices. We can point you to tools, other drafts that exist.
Right, but if you take a look at your various profiles, there are profiles that are basically, yeah, it's a cheap device, no security or very little security. And because of that other piece of the model, you need to start thinking about, can we actually afford those level of profiles?
Okay.
Dan York. So I would agree with Mike, actually, that threats from is an interesting thing to consider, but I was really more coming up here to ask a practical question, which was just, how do you want the feedback as far as email to the authors? But I notice you're using GitHub. Do you also want GitHub issues, or how do you work? I'm new to this group, so.
At least I, as a author, is fine with GitHub or email, whichever you prefer.
Thank you.
Yeah, and if you send emails, preferably send to the whole email list, and also the GitHub tracker. But as in general at the IETF, we prefer to have the discussions at the email list, but GitHub tracker is good for the issues.
Jason Livingood, quick note, it may be worth using as a reference or looking at it for some of the security challenges and so on. There's a paper coming out on Monday or Tuesday from the BTAG, which is the Broadband Internet Technical Advisory Group. I'm one of the co-editors that goes through these issues. So you might be able to, some of the sections that you still need input on, sort of pull directly out of that document. So Monday or Tuesday, it'll be out.
Please send it on the list, but I would also say there's a bunch of people writing guidelines. So we have the Cloud Security Alliance, we have the GSMA, we have the Trusted Computing Forum. Everyone is, writing guidelines. So I don't think we can make everyone happy, but definitely we can take contents from the paper and add where necessary.
Lee Howard, kind of responding to Mike's point and also your response that, yes, we should be thinking about threats from, but in many cases, in many ways at least, we can prevent threats from by preventing threats to, right? So if we can say, here's a collection of problems, if you follow all of these security pillars, then you have at least reduced the possibility of attacks out, right? I'm only about 8 pages into the document, yeah.
Yeah, that's what I said. I need to reduce the length.
Niels ten Hoever. I think it would be tremendously useful, speaking to the earlier point, to link to the other guidelines. So that would at least say they are around, you can have a look at them and you can compare, and that would already be tremendously useful.
Sure, good point.
Okay, thank you, Lloyd.
Okay, so that was a good overview of some of the key security work we have at the group. And as Carsten mentioned earlier, there are a couple of topics that we have had in the group. One is security for IoT, another is this, how do we do REST in the IoT world? So I'm going to give a quick overview of the RESTful design work that we have been doing here. And this is an overview of a whole bunch of documents. So I'm co-author of one of them, but there's a lot of documents from Michael Koster, Klaus Hartke, and Matthias Kovac. So if we somehow try to split the work in different areas, what we have on the area of RESTful design, we can say that we have some documents focusing on guidance, some on hypermedia language for IoT, and some work on hypermedia apps. If we start for the guidance, there's all those smaller boxes are drafts that we have at the working group. We have the RESTful design for IoT systems, giving high-level overview on what kind of systems you should be designing here. We have the core application descriptions, which is somewhere in between guidance and on the hypermedia language. A couple of documents on hypermedia languages, Coral and HSML. I will have more details coming on the follow-up slide on all of these. And then also a CBOR encoded form data that is closely related to the Coral document. And on the hypermedia applications, there's one older document called Core Lighting. That was the first document that we were discussing in this space. But now there's a brand new document called Thing-to-Thing Data Hub that you should probably have a read if you're interested in that topic. But also this work relates to a lot of the work we are doing in the core working group, so being Resource Directory, BAPSA Broker, etc. So if you go to details on the documents, on the RESTful design document, this is one of the documents has been quite some time work in the research group, and it's really about guidance how you design these RESTful systems with the IoT aspects in mind. So it's a collection of, you could say, basic information, something you can give as a relatively new person in the field and should be able to grasp some of the key concepts. But even those who are more experts in the field have been finding useful things in this document. And also it's a lot of terminology. So which words are we using for what things is always an issue in documentation and in discussion. So it's trying to clarify some of those terms that we think are important in the field. But as I said, the key difference in this document compared to all the other RESTful guidance out there is that we are trying to take the IoT angle here. Like what kind of things in specific should you keep in mind when you're designing an IoT system in the REST world? So we are discussing, for example, data formats, interaction patterns, and other mechanisms that make it suitable for situations where you want to minimize the human interaction to devices talking or things talking to each other. And then, of course, a lot of our focus is on the constraint end of the IoT spectrum. So how can you make these things possible in a constrained environment, constrained networks, constrained devices? And the draft, the last bullet is the name of the draft. And as Karsten mentioned, we think that draft is getting ready for research group adoption. There's a whole bunch of issues on the GitHub issue tracker, which we are still planning to address. We're going to address a set of them, submit a new version, and ask for group adoption. Then another document on the area of guidance is this core application descriptions. This document from Klaus Hartke. And the idea of the document is to how you can describe APIs that are constrained RESTful hypermedia-driven applications. So what kind of controls you would have in this kind of API? What is a standard way of describing them? So when you do an API that is using this kind of mechanisms, that they are actually understandable for everyone else and also following a standard form. So you have URI schemes, media types, how you do link and form relation types, how you set up form names, etc. And that's a draft Harke core apps if you want to see details. Then we have this another whole field which we call the hypermedia language for IoT. And the idea here is that how you can express the kind of things you would have in a hypermedia. So you have controls, links, and forms, etc., that you can still use in a format that is friendly for the IoT things. So as in layman terms, you could call this HTML for IoT. However, whereas in HTML, a lot of the focus is on how you can have structured data presented in a generic way, this one focuses more on the control side. So how you present links, how you present forms, etc. And there's also a lot of related work going on at the W3C Web of Things that Matthias presented earlier. So you should also check that area out. So then if we look a bit on the details of the languages that we are working on right now. So Coral, the constant RESTful application language. The idea there is to have an efficient way to represent forms and links in a hypermedia. So it is using CBOR, which is a way to express JSON-like structures in a very efficient way, suitable for IoT devices. It set up a host of defaults, so you don't have to send every value every time because it has a sensible default values for a lot of things you will be working on. Instead of string IDs, it's using numeric IDs, which are in general more efficient in this kind of environments. And overall, thanks to all these mechanisms, often it's only a few bytes that you need to be exchanging in the interactions with the hypermedia. And also, even though focus is on the controls, you can also embed representations in some of your messages in that way to reduce the amount of round trips you do. So instead of just always having to follow a link, you can also have the link representation in band. And the idea is to be able to have this in a simple implementation, something like a class 1 device. It's only a small amount of RAM and flash, and still be able to interact in a full hypermedia way. So there's 2 different drafts that are related on this topic. And then we have HSML. This is from Michael Koster. So here the idea is to have a combined core link format and SendML and have something called HSML collections. This is also using JSON and Seaboard for the representations, so it has a lot of similarities for the Coral. However, the key thing here is to use link annotations for describing the application semantics. And there you have the draft Koster using RG HSML for reference. So at this stage, you may wonder, why do we have 2 different documents? Well, one thing is, it's a research group, we are exploring what is a good way of doing things. And we have been thinking, comparing these 2 different approaches and what are the similarities and what are the commonalities there. So similar things here, both use collections of links and items. So they follow a similar pattern there. They use hypermedia controls to perform resource state updates. They have interoperable data models, as is custom in here. And also, actually, as Michael pointed out, HSML can even be encoded as Coral. So they have a lot of commonalities. But there are a few differences too, which we are now looking into. For example, Coral, the data model is derived from HAL, the hypermedia application language, whereas, as mentioned, HSML is more on the core link format and SendML and exploring how those together can be used in an efficient way. Also, Coral used media types heavily, and HSML is focusing on link annotations. So those are the similarities and differences between those 2 documents. And what's right now ongoing work is that figuring out what situation, what kind of mechanisms make sense in what kind of environments. So there's experimentation on use cases and implementation of this. And the idea is eventually to converge to a single solution. But right now, we are exploring both of these tracks. And then the whole area of hypermedia applications. So what kind of things we can actually build on the tools that we have in our toolbox. Core lining is one of the earliest documents that we had in this space, and that was also by Klaus Hartke. It was about how you can control smart objects in a small smart home environment, simple lining scenario in that context. That draft is currently expired because other drafts have newer material, but there is maybe a plan to later on update that using the latest things, for example, Coral. However, there's a brand new document in this space called the Thing-to-Thing Data Hub. And the Thing-to-Thing Data Hub is really a RESTful hypermedia-driven web application that you can use for storing and publishing information on a central location. So it has a lot of similarities with the resource directory, with the PubSub broker, with the old mirror server, etc. Trying to generalize these concepts and look at them in a bigger picture with the proper hypermedia controls. So what it supports the kind of functionality, of course, it has functionality to discover this data hub. You can read information from it. You have the usual create, read, update, delete semantics, and also with observe, supported by CoAP. And it also supports simple source query semantics, so you can find what kind of things the data hub is storing. But the key thing in the Thing-to-Thing Data Hub is this evolvable API based on hypermedia. So whereas a lot of the work we have been doing in the core working group so far has relatively static API defined by the URI templates. So you have a one URI where you post and then maybe you discover links, etc. But this is aiming to be the really fully RESTful way, using only proper hypermedia controls to achieve same things. And there's the draft on that one. So that was an overview, rather quick overview because we are low on time. So it's a whole bunch of documents in a pretty interesting area on the hypermedia applications. So please read the documents, and if you are interested in one of any of those, send review comments on the list of the authors, and hope you guys are able to participate in the work. Any questions, comments? Okay, if not, I guess we can have last one.
Thanks. I'm actually surprised how you managed to present all this information in time. I was already thinking, okay.
Promise.
Yeah. So Today hello everyone, my name is Alexander Pelov and I'm going to be talking to you about a thing that is a little bit at the fringe between the research and the reality that we'll be seeing coming. I imagine that most of you know what co-op is and the IoT part of the world. And I would like just to see a raise of hands how many of you know what Yang is. Okay. Yeah, so most of the people know what Yang is also, so it will be also an easy, maybe they think that. So first, a couple of thanks, and I will breeze because I have something like 30 slides. So you'll see a lot of slides actually not being shown for very long. A big thanks to the chairs and to many people that have actually with whom we have had a lot of discussions about all this RESTful way of making applications, and that actually gave a lot of the ideas that led us to think about this small little picture there, which with nice colors, but maybe not that readable, is what we have here today. So maybe some of you have heard about ComI or not. So ComI is the netconf or the RESTconf for IoT. So we bring the Yang world to IoT. And what we see today is that you have this huge part of the Yang community here that are basically doing for routers and for big stuff. And the IoT is very small compared to this. So first thing that I would like to send as a message for you is that in reality, we think that things will look more like this in the future. Because, you know, the modules of Yang that you see, well, you know, you don't have like billions of types of routers out there, but we will have billions of devices. So right now we say that, okay, Yang can serve all this area. And actually, in fact, we say, yeah, so Yang will be everywhere. Well, of course, there will be some parts that will be non-completely Yang. It will be very small, of course, but this is maybe a completely RESTful view will be there. So I hope I got your attention. And what I'm going to be talking about here is an interaction model for making IoT applications and for managing IoT devices with Yang. So what I'm not going to talk about is how we are going to replace all the things that we've been doing in core. And I'm not going to be talk about how we are going to be replacing the things that Ari was talking about. You know, how you do the web linking, how you do the gateways, how you do RESTful, pops up, and all that stuff. So these are things that remain completely valid. And I'm not going to be talking about how you replace the semantics and things like this. What I'm going to be talking is that this is a way that actually allows you to have a much richer way of communication and interaction between the devices, either in a thing-to-thing fashion or from a centralized to thing or a thing device. So here we have a good definition of what an interaction actually is, because that was not an easy thing to find out. And I will leave you to read, you know, you can get all the slides from the presentation. Well, what's not an interaction? Well, when you have like different things talking different languages, having different representations of the data. So what is an interaction model description? For example, in a RESTful application, well, you have links, you follow the links, then in these links you get some content formats, and then you find out how to submit some forms, and then this is how you go from one device or from one resource to another, and this is how you interact with this end device. So now, and this is an example. So you have like a simple request that says put and you have some resource, and on this resource you have some data representation and the value 25. So you put some temperature there, and then you have some answer says, okay, that I updated I updated this for you. So you know, this is like a method, the URI that and the syntax and the data variables. So the question is how you actually know. So this answers a lot of questions about how you actually interact with this device. And this is actually provides you with the semantic of what you are doing there. So now the big question is, how do you know? So how does the client knows that here actually the client must send 25? So that this is temperature, that is in degrees. You know, you went through all the parts. You found that there is a URI, and you found that you can do a put on it, and then you come there and okay, why not just put like a string? What can indicate me what I can do with this link, or how can I know that? For example, a very huge value, a very huge integer, is not a valid thing to do. Well, of course, when you do RESTful APIs, you have this, and you have this in Coral, you have this in the other thing that I forgot what is the name is. You have a way to get this information. And one of the ways is, for example, you have like content type here that will indicate you, well, this is the type of content which you can give to this resource and which you can get from this resource. And this way you will interact with it. So let me present you with another alternative to this. So of course you can use your RESTful APIs, you can use your RESTful way to finding all links and all resources, and then at some point you stumble at a thing that is marked as being commie or as being young. So when you do this, so you discover it, and when you do this, you can actually send a much richer set of interaction. You can have a much richer set of interaction with this entry point. The thing that is really important here is that Yang actually has a way to defining schema. So you can get the model of interaction with this point. So you can know, okay, I have under this point I have a temperature, and this temperature is expressed in Celsius, and this Celsius can be from 0 to 200 degrees Celsius. So you use your RESTful engine to get to this point, and then you know how to interact with it. You know that you can have temperature, humidity, or something else. You can get some values. You know some values that can be read-only, and so forth. So all these things are already there, and they're well understood by more than half of you now in this room. So you know about the Yang. You know how to describe this interaction. So basically, it comes like a medium-term solution that gives actually quite a lot of power, between the fully RESTful application where you have the hiatus, and when you go and you discover all the things and you need to understand them. Here you have all these things that are already there. And we have the protocol that is there. So commie, the protocol, which is under discussion a lot in the core working group. And we have all these mappings that allow you to do this actually quite efficiently. So, okay, I think that was the last slide. It flipped over. With this, I would like to submit to you that we have the RESTful way, that is like and the hiatus way, that is like the long-term ideal vision of the world, and we have the same thing -1 that is a little bit much closer, and which can give you a lot of the things that we are actually that we care about, how we build applications in a in a specific and concrete way that work today and that can scale for the IoT. Thanks.
Thank you. So, whose heads are spinning now? Nobody's head is spinning.
30 slides.
Whose heads are spinning in a comfortable way? I mean, who liked what they saw in the last hour here? Nobody liked what they saw. Who did not like what they saw? Who would not come to another meeting of this group? Okay, I can't people to raise their hands. Thank you for coming anyway. We're likely to have further summary meetings of this kind here. And of course, if you're active in the research group, you can suggest topics that we are talking about at these summary meetings. And if you are not active, you also can suggest topics that we should be talking about. So with that, enjoy the plenary.
Great. I think I have pretty good notes.